Hi everyone, welcome to Devlog number 8. Here I'm going to be showing how I solved the crouching for player physics with the player rig setup. This is the player rig setup, and this was made by Tim Carlin. But first, thanks to my patrons. Without you, this wouldn't be happening. Now onto the video. Here you can see the player rig setup with the arms and the head and the body. And the issue that I had with this, and this is a big issue for a lot of users, or it was, is that the Blender game engine has different physics types. It has character physics, it has static physics and dynamic physics, and rigid body. So unless you use character physics in my open world system, it sends the player flying and it tends to be very unstable. So I needed to work with the character physics. The only issue is that the player character physics cannot be distorted, or it can't have children and inherit the properties of those children, like for instance other collision meshes. And this is a problem when you need to change the size of the collision mesh, like if you were to crouch under a table. That's a really big issue, and in the game where you need to hide, crouching is very important. So you can't use an action because it actually causes errors. Anything that's a child of the collision body object here, for instance in this case the armature and everything else, everything that's a child of that inherits the animation and any errors that might come with that animation if they are as well being animated. So I couldn't use actions. So I found a way to use the lerping code to scale the player down along the z-axis like so. So now when I press C to crouch, the player crouches. And you can see there's a little bit of a tweening animation there, and that's because I'm using the same lerp code from the menu lerping to get a nice easing and smoothing motion, so it's not just a very robotic crouch. So that's the code here. So I simply repurposed the lerp code that I did for the menu to do crouch lerp. And there was another issue. So this is very complicated, but when the player is now crouching, all the child objects, in this case the armature, the weapons that are equipped, and indeed all the animations, and even the mouse look motion, it's being scaled by 50% or by whatever the crouch height is. In this case, I think the crouch height is 0.6%. So you can see it squishes the arms and causes a major issue because it took the z-axis of the head and squished it because the body got squished with everything else. So I needed to figure out a way to get around that. The way I figured out to get around that was simply to take the head object and scale it in the inverse. So whenever the body scales by 50%, the head will scale by double that, so 2, double its own height. So the simple mathematic expression here, or I guess you'd say it's not mathematical, but it's the it is math. It's right here. It's the head local scale 2. So the 2 there in that list is z, because it's x, y, z. So in the local scaling with 3 coordinates, that's x, y, z, which is 0, 1, 2. So 2 is z-axis. So the local scale of the head, in this case, which is the head which contains the armature and the mesh animations and the camera, those all need to take the standard body size, which is 1. I could also just say the head local scale, which is 1. And then as the body scales along its z-axis, to divide that by that same number at 1. So if I take 1 and I divide it by 0.5, then head local scale becomes 2, which is double 0.05. So if I uncomment this piece of code here and save it, now when I run the same game script, you can see now when I crouch, the head object is being scaled as the crouch happens. So this counteracts the scaling issue, and there's no bugs anymore, and there's no hiccuping too. So this is how I've solved the crouching physics problem in the game. So now I can use the player physics. I can run around the world without having to worry too much about the crouch problem happening, and this will be a much more stable collision box for the player to function with. So when I bump into walls, I won't accidentally spawn into them maybe a little bit and then get kicked across the level. So this is a more stable system for the Blender game engine. Now other game engines have kind of already tackled this hurdle, but because I'm left with what I'm working with now, this is what I've chosen to do, and it's working pretty well so far. So I can actually test this system in the open world. Of course, I'll be making an example of this of this rig, and I'll be putting it up on my Patreon so my patrons can see how the script is working. They can tweak with it. They can tweak it and see how the values change the motion of the player, and how it is a little bit more stable than if you were to use different systems. Some of the other systems I tried were, thanks to Tim Krellin, changing out the collision box with a different size collision box. And that's great if you're not using character physics. Unfortunately, when you use character physics, you can't replace the character mesh, or you can't re-instance the mesh unless it's made with polygons. But we wanted to use the capsule shape because that's a more computationally efficient and also a more consistent way of calculating physics. So here you can see, as I press crouch, now the player crouches. And you can see there's actually a little bit of a whoop motion. That whoop motion is the tweening motion that I coded in to the menu function so that the menu cam will bounce back and forth. So now the player successfully crouches and comes up. And this is almost like a very overwrought and complicated system simply to solve a very, very small and nuanced problem that, you know, the Blender game engine just simply never plugged that hole. But now this is how I solved it. Going forward, this is probably something that would need to be fixed if we were to fix up the Blender game engine, or to make it more in line with what standard game engines would expect to operate as. But for now, this works great for my purposes, and it's stable enough that will make the game, that'll make this experience very seamless, the experience of crouching. So you can see I can hammer away at the crouch key, and in the middle of the crouch I can actually change back and forth. So a lot of game engines would call this like a ping pong action, where you're ping ponging back and forth between an action, but in my case, it all needs to be handled through code. Anyway, thank you all for your support, and I'll be compressing this and uploading it, and thank you once again.